Number 16. Which statement is correct about the critical point of a phase diagram? If you know the definition of a critical point, you should know the answer is B. Liquid and vapor are indistinguishable from one another. Let me draw the phase diagram. On the horizontal side, I normally have temperature, and on the vertical side, I have pressure. And I have three lines that converges, and the point at which it converges is the triple point. It's the state in which the liquid and solid and gas can coexist. However, the question is not asking about the triple point, it's asking the critical point. Okay? You do know that the very left side I have a solid region, liquid in between, and between the solid and gas, and the gas on the very right side. The orange dot I just drew is the critical point, and this is the ending point of this line. Okay, the line between the liquid and gas. It won't extend after this point because after that the liquid and gas become indistinguishable. So answer is B. Number 17. When equal volumes of the following pairs of liquids are mixed thoroughly and allowed to stand, which pair is likely to separate into two layers? It's testing you the concept of miscibility. You need to know the polar and non-polar do not mix well, so we have to choose a choice that has polar and non-polar. If you have polar and polar or non-polar and non-polar, they will mix very well and you will not form two different layers. Ethanol and methanol both are alcohol and they are very polar. They have the functional group of OH minus that tend to evoke the hydrogen bond between them as an intermolecular force. So polar and polar, this is not the choice we want. Carbon tetrachloride and methanol. Carbon tetrachloride has a symmetric shape and it's non-polar. Each bond between carbon and chlorine becomes 109.5 degrees and it's strictly non-polar. However, the methanol has a dipole and it's alcohol and it's polar, and also it has hydrogen bond, so they will not mix very well. So answer is B. Hexane and the pentane are both non-polar because they are hydrocarbons, and carbon tetrachloride we already talked about. Hexane, again, they both are non-polar, so they will not form two different layers. Number 18. For the same atoms at the lattice point, which lattice exhibits the lowest density? Okay, we can start this with unicell, and let me illustrate it with a simple cubic. Okay, I'm drawing this in perspective. So that's the simple cubic. In the center I have nothing, it's all empty. It's just the lattice points that it's made of the atoms. Okay? And moving to the body centered, it's the same shape except I have a center sphere, so creating higher density, so A is out. And the face centered cubic, that's like I have a semi-sphere on each side of this cube, so I have 6 semi-spheres. That's even more dense. That's even denser than the body center cubic, so B is out. Now the hexagonal can be confusing because that's more the closest packing concept. Hexagonal, and you will see like HCP, meaning the hexagonal closest packing. As the name implies, this is to minimize the space in between the neighboring atom, so they will be very dense. And so our best choice is to go with D, the simple cubic. Number 19. Okay, sample of sodium hydroxide was added to water in a calorimeter. The temperature was monitored as the sodium hydroxide is dissolved to give the data below. Determine the heat released during the solution process. Okay, we are mixing the water and the sodium hydroxide. It's a strong base and it's gonna release heat. We have 110 grams of total solution. Okay, before I write that, let me start with the formula. The Q, the heat transfer, heat flow equals the mc delta T. M stands for the mass of our system, C stands for the specific heat capacity, and the delta T stands for the change in temperature. Normally at any time you see the delta, it's the final minus the initial. So we have the mass of solution and the capacity, heat capacity for the solution, and the temperature. So we have 4.184. Actually they gave you only 4.18 here. So I have joule per grams per. Now it's given Kelvin, and the Kelvin has the same unit width as that of Celsius. So I can write the degree Celsius instead, and then I have change in temperature. Now the final temperature of the solution increased. And when you calculate this out, you're gonna get 1.11 times 10 to the 4th joule. Or just kidding. And that's our answer. So to recap, when this becomes dissolved in water, the solution the solution is releasing heat, and there was a heat flow out of the system, making it exothermic. So answer is D. For which of the reactions below are or is the heat of reaction equal to the heat of formation? You need to know the definition of heat of formation. That's the energy that's required to form a compound, and that's 1 mole specifically. You need to meet 2 conditions, one of which is it has to be standard state at 25 Celsius degree, 1 atm, and that's not really emphasized here. What's important is that the reaction has to be made of elements. The compound we are trying to form has to be made in the reactant side. That every element must be shown instead of molecules like 2. So 2 cannot be the H reaction here that you see is not gonna be the same as the heat of formation, because it's not made of elements to form sulfur trioxide. Okay? Had we had sulfur and oxygen only, then this would have been possible, that the heat of reaction is equal to the heat of formation. So 2 is out, so any choice that has 2 is gone. And so you are left with A or D. If you look at the first choice, we have a nitrogen, which is pure, we have an oxygen, which is an element, and they make up the nitrogen dioxide, and that's equivalent to, this was not right, unequal, and in this case we have the delta H for this reaction is completely equal to the heat of formation of the nitrogen dioxide. So the only answer here is A.